Okay, we're going to get started with 6.2 today. So we're going to cover 6.1 and 6.2 this week. So I am going to bump 6.3 to next week. We'll cover it Tuesday of next week. So I'll change the due dates and all that in Math Lab and put the 6.3 videos next week in week 11. Okay. Now what 6.2 is covering, it's called factoring trinomials. Trinomials just means it's going to have 3 terms. It's called factoring trinomials with leading coefficients of 1. So not only do they have 3 terms, the leading coefficient being 1 means the number in front of the x squared is going to be a 1. Okay. For instance, like in number 1, you have says complete the factoring, and it does part of it for you. It's kind of like we're going to figure out what did they FOIL together to get this trinomial. So if you have x squared plus 10x plus 24, and it tells you, so they have 2 binomials. So this right here, they're saying, what did they FOIL together to come up with this trinomial? And they're actually going to give you on these first couple of problems what is in the first parentheses, which in this case is x plus 6. So let's think about this. What they want you to figure out. Remember FOIL. This term is going to go to that term. We're going to multiply x times what? And you need to come up with x squared. So what would that missing term right here be? What do you need to multiply x times to get x squared? Well, you would need to multiply x times another x, right? X times x is x squared. Now, let's think about the last part of FOIL. When you multiply this number times that number. So now we're going to figure out that missing term. This missing term needs to multiply to 24. So what do I need to fill in? If I already have the 6, what do I need to multiply 6 times to get positive 24? Well, I have a positive 6, which means I need to multiply that times a positive 4, right? Because 6 times 4 gives you 24. So x plus 4 is your answer. That's what goes in that missing parentheses. Now, let's fully check this with doing a full FOIL on this. So, like we said, we needed x times x. That gave me x squared. Then we had x times positive 4. What does that give you? If you have x times positive 4, that gives you positive 4x. Then you did your inner, right? After you do outer, then you come in and do inner. Well, what's that inner going to give you? I've got a positive 6 times x, which is positive 6x. And then my last, and this is the number that I put in, positive 6 times positive 4 is positive 24. And remember, look at those middle 2 terms. What do you get when you add the 4x and the 6x together? When you put those together, it gives you 10x, right? So that is what I started with, the x squared plus 10x plus 24. So x squared plus 10x plus 24. So the main thing we're going to have to worry about in this section is going to be our signs. The second one, you have x squared minus 9x plus 20. Again, it gives us two parentheses, but it fills in the first one. And it says the first parentheses is x minus 4. So let's do our same thing again. My first x times what I'm going to put here, and what do I need it to be? X squared. Well, that automatically means it's just another x, right? That's the only way to get x squared is x times x. Be careful with your signs here. Then I'm going to jump straight to my last. What do I need this number times what I'm going to be putting here to equal? I need it to equal positive 20. What do I have to start with? I've got a negative 4. What is going to be my sign? Think about that. What are you going to need to get a positive 20 by multiplication? If you've already got a negative, you're going to need another negative, aren't you? Because you have to have, if you've got one negative and you're going to multiply it in order to end up positive, you're going to need a negative times a negative. And what am I trying to equal? 20. So I need negative 4 times negative 5. Now, the rest of these are going to give us this trinomial to start with and ask us to come up with the factors like this, but they aren't going to give us any part of the answer. R squared plus 4r plus 3. Okay, let's talk about the setup. First of all, it's a trinomial. Factoring trinomials, so there's 1, 2, 3 terms. That's what makes it a trinomial. With leading coefficients of 1. Well, what does that mean? That means this is my leading term, right? The term that has the highest exponent is going to be your leading term, which means its coefficient is going to be the leading coefficient. Okay? If you don't see the number in front of x squared, what does that automatically mean this number is? R squared in this situation. R squared means 1r squared. So these I call the good trinomials, because if you're starting off with r squared, there's only one way to get that. How do you multiply two things together and make them be r squared? The only way you can do that is with an r times an r. So there's your first part. Now, the second part says this number, the numbers that I'm going to put in here and here, have to do two things. They have to check off two boxes. The first box they have to check off is they have to multiply to equal whatever this last number is. So let's go ahead and make a list of all the numbers that will do that. And we are lucky on this one because it's just a 3. The numbers that multiply to give me 3 are 3 and 1. So that's the extent of that list. Now, the second thing that these two numbers have to do, after they multiply to equal 3, you choose the pair that also adds to that middle number. And what is my middle number? A positive 4. Well, here's my only pair that I have to choose from. And does it add to positive 4? Yes, positive 3 and positive 1 is positive 4. So that's exactly what you have in your answer, a plus 3 and a plus 1. When your signs are the same like this and they're both positives, it doesn't matter where you put the 3 and the 1. It can go in either spot. You could have put 3 here and 1 here like I have, or you could have put 1 there and 3 there. That's only the case if your signs are the same. Now, so this is your answer. That's what you put in. That is your final answer. Let's think about how we would have checked this, okay? So starting in chapter 6 is when we're doing the factoring. When we did chapter 5, we were given this as the problem and asked to multiply these two binomials together to see what we got. So that's how we can check this. Let's check this by FOIL. My first, r times r. There's your r squared. What's your outer? R times positive 1, which is positive 1r. What comes after your outer? Then you jump to your inner. Positive 3 times r gives me positive 3r. And then your last, positive 3 times positive 1 gives me positive 3. And when you put your middle terms together, since they're like terms, you will have r squared. Put those together to get 4r plus 3. So that's how you know that it checks. So if you multiply it back together and you get the trinomial that you started with, that means you did it right. Let's do a couple of more with simple numbers like this before we get into numbers that are more difficult. I want you to get used to doing signs, finding factors. So let's try another one. X squared plus 6x plus 8. So trinomial, leading coefficient of 1, right? 3 terms with a 1 in the front. That's what tells you you automatically start off with x and x. Then what are you doing? You're finding the factors of this last number. So this time I'm trying to find all the ways to multiply to get 8, which would be 8 times 1. There's another way to multiply to get 8. 4 times 2. So this time I have 2 different pairs to choose from. After they multiply to give me 8, then they need to add to give me that middle number. So let's see. Does this add to 6? 8 and 1? No. Does 4 and 2 add to 6? Yes, it does. So I'm using a positive 4 and a positive 2. All right, let's start talking about signs. Let's say I have the same trinomial, except that's a minus. Starts off the same, right? X and x gives me x squared. Still multiplying to get 8, so I'm still going to use these pairs. But this time I have to add one of the pairs together to give me -6, which means I need to think about what kind of signs are going to do those two things. How do you multiply to get a positive? What are different ways to do that? Let's see, to multiply to get a positive, I either need to multiply 2 positives together, right? That'll give me a positive. What's another way to multiply to get a positive? Well, you can multiply a negative times a negative together, right? If you're multiplying two negatives together, is it your answer positive, right? What's the sign rule when you're multiplying? If your signs are the same when you're multiplying, your answer will be positive. So if I'm going to multiply to equal positive 8, but add those numbers together from my pair and get negative 6, what are your signs going to have to be? If you're multiplying to equal a positive, your choices are two positives or two negatives. If you are going to add the same two numbers together and equal a negative 6, you're going to have to use two negative numbers, right? That's how you multiply to equal a positive and at the same time add to equal a negative. I'm still going to use my 4 and 2 pair because I'm still trying to get that 6. I just need it to be negative 6. And once again, if your signs match and are the same in your answer, it doesn't matter which spot you put the 4 and 2 in. Okay, let's do another sign situation. Once again, trinomial with 3 terms, leading coefficient, the number in front of x squared is a 1. That's what starts us off nicely. If your leading coefficient is a 1, it is automatically x and x. What do these two numbers right here need to do? They need to, first of all, multiply to equal negative 15. I could go ahead and put my signs in. How do you multiply to equal a negative? Well, your signs just have to be different, right? Either have to have a positive times a negative or a negative times a positive, right? That's how you multiply and get a negative answer. So just go ahead and put your signs in. You can't mess up where you put your signs. So it doesn't matter if you put the plus here and the minus here or vice versa. It makes no difference. I just know they need to be different, right? You have to have one positive and one negative to multiply to equal a negative 15. Now, let's come up, don't worry about the signs right now. Let's come up with the ways to multiply to equal 15. Let's see, I need a 15 and a 1. We'll do it. And what else? A 5 and a 3. We'll do it. I already know that when I put my numbers in, I'm going to have one positive number and one negative number. What are the pair going to have to do? After they multiply to equal negative 15, they're going to have to add to positive 2. So first of all, let's think about which pair is going to make this happen. Are you going to, no matter what you do with your signs, are you going to make a 15 and a 1 ever give you a positive 2? You're not, right? So I know it's not that pair. Now, I can work with the 5 and the 3 if I manipulate my signs to equal positive 2. Now, let me tell you a little trick. When your signs are different like this, you come over here and you look at the pair that you've chosen, and you put the bigger number, which is 5 out of this pair, right? Your bigger number needs to go with whatever this sign is. This sign right here is kind of telling you what you need more of. I need more positives than I do negatives if I'm going to add the two numbers together and end up on the positive side. So who of these two numbers needs to go with the positive? Who's the big number? 5. So 5 goes with positive, 3 goes with negative. then you can do a quick check. These two numbers, like we said, need to do two things. They need to do this situation and this situation. So multiply them together. What's positive 5 times negative 3? Negative 15. What is positive 5, negative 3? If you add those two numbers together, 5 minus 3 gives you positive 2. Let's try another one with different signs. Trinomial, leading coefficient of 1, automatically x and x. If this is a negative, which is telling me that I have to multiply to equal negative 24, I automatically know my signs are going to be different, right? That's the only way you can multiply to equal a negative is with different signs. If I'm multiplying to equal negative 24, I'm going to need a positive number times a negative number. So go ahead and put them in. Remember, it doesn't matter where you put the signs. What matters in a minute is what number you put with each sign. That's what matters. So let's come up with our list of numbers to multiply to get 24. We're getting a little more complicated because we're getting more pairs now. There's more ways to get 24. 24 times 1, 12 times 2, 8 times 3, and 6 times 4. Lots of ways to multiply to get 24. So let's see, I'm going to have to pick one pair. Now remember, I'm going to have a pot. When I pick my pair, one of them is going to end up positive and one of them is going to end up negative. And what are they going to need to add to do? Get negative 5. So a lot of times people will be able to pick out the pair and then have trouble with which number goes with which sign. Are you going to be able to get a negative 5 from a 24 and 1? No. What about 12 and 2? You're going to be able to add that together and get any kind of negative 5? No. But look at this one. Won't those numbers, just looking at 8 and 3, you should say, I can do something with my signs to make that add to negative 5. So remember what our trick is. This sign tells you what you need more of. You need more negative if you're going to end up at negative 5. You're going to need more negative than positive. So when I come and I look at my pair, if I need more negative, I'm going to need my big number to be the negative number, which means 8 has to go with the negative number and 3 goes with the positive number. Multiplies to negative 24. Positive 3 times negative 8 is negative 24. And adds a positive 3 minus 8 gives me negative 5. All right, let's go back to our homework. Look at number 4. You've got p squared plus 6p minus 40. Trinomial, right? It's got 3 terms. Leading coefficient is a 1, which automatically makes it p and p. What are you multiplying to get? Negative 40. What does that tell you about your signs if you're multiplying to equal a negative number? That means I'm going to have different signs, right? That's how you multiply to get a negative, is with different signs. So let's make our list. 40's got a lot of ways to get it. 40 and 1. 20 and 2. Let's see, 3 doesn't go into it, but 4 does. 4 and 10. 5 does. 5 and 8. No 6, no 7. Okay. So that looks like our options. What do I also need the numbers that multiply to get negative 40 to do? I need them to add to positive 6. Let's pick out our pair first, and then we'll worry about the signs. 40 and 1. Am I going to make that a 6? Nope. 20 and 2. Am I going to make that a 6? No. What about 10 and 4? Yeah, I can do something with those signs and make that a 6. What kind of 6 do I need? I need a positive 6, which means I need more positive. If you're going to end up at positive 6, you're going to have more positive than negative. So let's see. If my numbers are 10 and 4, and I need to end up at positive 6, who needs to be positive? Well, if I need more positive, I'm going to need my big number, which is 10, to be positive. My little number, which is 4, to be negative, because that will multiply to negative 40. Yeah, positive 10 times negative 4. And add positive 10 minus 4 gives you 6. Now, I'm going to show you a trick in your calculator. Because what I've noticed through the years is that a lot of times what people have trouble with is, especially if you get numbers like 100 or something right here, is trying to think of all the ways to multiply to get it. So I'm going to show you a trick in your calculator. All right, go to your Y equals button right here. Hit it and make sure it's clear. Whatever number you're trying to multiply to get, the sign and everything, which in this case is negative 40. Put that in. So remember, the negative button's below the 3. So you'll have negative 40. Then hit the divided by. Then you're going to hit X, which is this number right here. Or this button. It's not a number, it's a button. So negative 40 divided by X. Now, what you're going to do now is hit the second button. And then come over here and hit this graph button, because look what second gets you to. See that word above there? It's table. Look what it does. It comes up with this list for you. All the numbers in these two columns multiply to give you negative 40. Right? Negative 1 times 40 is negative 40. Negative 2 times 20 is negative 40. Just don't look at anybody that has a decimal. Okay, but if I go down, let's see, negative 10 times 4 is 40, negative 40. So see what I'm saying? It comes up with all the ways to multiply to get negative 40. Positive 10 times negative 4 is negative 40. Positive 8 times negative 5, negative 40. Again, these two columns, when you multiply them together, give you negative 40. So if you want to use that, that will help you make these lists. Okay? So it helps you make the list. So then what are you doing? You're just going through that list and you're trying to say, okay, so all those ways give me negative 40. I need to find the pair that adds to positive 6. I'm going to show you another trick. Again, go back to your y equals. So to get the ways to multiply to get negative 40, I did negative 40 divided by x. Now go down to the second y equals. Type the same thing in again. So negative 40 divided by x, I'm going to type it in again. Negative 40 divided by x. Then I'm going to do something else. I'm going to hit plus, and then I'm going to hit that x button again. So you should have the same thing in the top, negative 40 divided by x, then do negative 40 divided by x, and then hit plus x. Now, we're going to go back to the table again. So hit second, and come over here and hit the table again. Look at this last column. Here's what this last column is doing. It's adding these first two columns together. So look, negative 4 plus 10 is 6. Negative 5 plus 8 is 3. Negative 2 plus 20 is 18. So here's what I'm saying is the first two columns multiply to give you negative 40. The third column adds the first two columns together, which means in this last column right here, I just need to look for the positive 6. So go scroll down or up, however you need to go to get this last column. Whoops. So there's my positive 6. So guess what these first two columns are? They're the numbers that multiply to negative 40 and add to positive 6. So once you find the positive 6, because of this in that last column, then look what the first two columns are. Positive 10, negative 4. Look what my answer needed. A positive 10 and a negative 4. Let's practice this some more. So I'm going to factor this trinomial. So it's got a trinomial. There's 3 terms. My leading coefficient is a 1, right? That's what's in front of the x squared is a 1, which is fine and good because when I am finding the two binomials that multiply to give you this, I need this times this to equal x squared, and there's only one way to do it, x times x. So it's automatically an x times an x. Now, what are we trying to do? Find the numbers that multiply to equal 100 and at the same time add to equal 29. So let's see, I can either make my list over here, 100 times 1 equals 100. 50 times 2 equals 100. And I can go on and on, or I can use this calculator trick and go hit your y equals button and then clear out everything that's in there from the last problem. So just hit clear and clear. So nothing's in there. What you're going to put in there is whatever this number is. So that number is positive 100. So I just put 100 divided by x. Now, if you hit the second button, and then hit that table button, what is it doing? It's making this list for you. It's listing out all the ways to multiply to equal 100. Right? There's my first pair that I had, 1 times 100. There's my second pair that I had, 2 times 50. So, I'm trying to find the pair that adds to what? Positive 29. So I can either just go through here and add them together to see which pair adds to positive 29, which I see right here at 4 and 25, right? That pair adds to 29. But if I don't want to do that, remember, I can put that third column over here that adds the first 2 columns together by going back to my y equals, going down, put your same thing in again. So again, I'm putting in 100 divided by x. And then remember, what do I put after that? I do plus x, plus x. And then go back to your table. So hit the second button, go back to your table. There is the column that adds the first 2 columns together. So I'm looking for positive 29, which I see right down here. Which means these are the 2 numbers that I need to use, a positive 4 and a positive 25. Positive 4, positive 25. Multiplies to 100. Adds to 29. All right, let's keep finishing. Let's finish our homework because we've got other things that we are going to run into. So let's look at number 5. Number 5 has s squared plus 6s plus 7. Again, trinomial, leading coefficient of 1, which means it is automatically s and s. What do your numbers have to do? Multiply to equal positive 7. You know what? I'm not even going to go to my calculator for this. I know off the top of my head how to multiply to equal 7. There's only one way to do it. So, what do the numbers also have to do? They have to add to 6. Here's where we're going to run into some trouble. How do you make 7 and 1 add to 6? Well, you would need a positive 7 and a negative 1, right? 7 minus 1 gives me 6. But what is 7 times negative 1? It's negative 7. I need the numbers to multiply to positive 7. If I'm going to multiply to equal positive, I either have to have 2 positive numbers or 2 negative numbers, right? That's the only 2 ways that you can multiply to equal positive 7. Do either one of these situations add to positive 6? Well, what's positive 7 plus 1? It's 8. What's negative 7 minus 1? It's negative 8. Neither one of these do that, which just means what this trinomial is called is prime. The numbers just don't work. There are no ways to multiply to equal positive 7 and at the same time add to equal positive 6. All right, what about this one? Y squared minus 5y plus 6. This one is probably one of the most missed ones. Starts off the same, right? Y and y for y squared. Let's see, what do I need to multiply to get? What's my last number? Positive 6. There's my options. If you wanted to, especially if you're worried about your signs, the way to make sure that you get your signs right is you can use this calculator. Go to your y equals and clear it out again. What number goes in? This is the number that always goes in. So I'm putting in a positive 6. Since it's positive, I just don't need to put its sign, right? Only put a sign if it's negative. So I'm just going to put in 6 divided by x. And I'm going to go down. And I'm going to do the same thing again, 6 divided by x. What am I going to put in after that? Plus x. Remember, this is your x button right here. Then I'm going to get to the table, which is second table. Now, then you jump over automatically to this last column. What are you looking for in the last column? This number right here. -5. So let's look in my very last column for -5. So over here, it looks like I need to go up. There it is right there. -5. What does that mean the numbers are that I need to use? Once you find your number in this last column, that means the first 2 numbers that are in front of it are the numbers that you need to use. So I'm using what numbers? -2, -3. Put it in. Take it to the bank. -2, -3. Your signs are right. Your numbers are right. Everything. Check it. What is -2 times -3? +6, which is what I need it to be. What's -2 plus -3 or -2 minus 3? -5, which is what I need it to be. So if you are unsure about your signs, use your calculator. All right, let's try another one. X squared minus 7x minus 18. All right, another trinomial with the leading coefficient of 1. And I like to call these, if they're a leading coefficient of 1, I like to call them the good trinomials. And you'll see why on Tuesday. When we start Tuesday, what our section is going to be on is trinomials again, but there's going to be a number in front of x squared, which takes it up a new level. Okay, but for now in 6.2, everybody's just x squared, which is good because it's automatically x and x. What comes after that? Let's see, I got to multiply to -18, add to -7. You know what? I'm just going to be lazy about it. I'm just going to go to my calculator. What number do you put in your calculator? Whatever this is. So this time I'm putting in -18 in my y equals. So go to your y equals and clear it all out again. Put in -18 divided by x. Remember, your negative button is below the 3. So -18 divided by x. And go down. The same thing, right? I'm going to put -18 divided by x, and then I'm going to put plus x. So -18 divided by x plus x. So that's what yours should look like. Then I want to see my table. So second table. Now, remember, you're always looking over here in your last column. And what are you looking for? This number right here. -7. So last column, looking for -7. So I'm going to come over here to my last column, scroll up or down until I see a -7. Well, there it is right there. There's my -7, which means these two numbers that make that -7 are what you need to use. I need a -9 and a +2. Doesn't matter where you put those numbers. It just matters that the 9 is negative and the 2 is positive. So a -9, +2. Does that do the things you want it to do? -9 times 2 is -18. -9 plus 2 is -7. Now, let's look at something else. This is what you're going to see like on number 8. You've got 8x squared plus 48x minus 56. What did I say? Minus 56. So this looks different because this time there is a number other than 1 in front of my x squared. But let me tell you what overruns everything. Anytime you are factoring in any way, the very first thing you look for is something in common like we did on Tuesday. If there is something that all three of these terms have in common, you have to pull it out first. Look at your numbers. You got 8, 48, and -56. So let's look at that. So 8, 48, and we're just going to call it 56. So I'm trying to find the biggest number that all of those have in common. So let's see. Remember, we did this on Tuesday. So let's look at our smallest number and find all the numbers that go into 8. Right? That'll make it easier so you don't have to find all the ways that go into 48 or 56. All the ways that go into 8. 8 times 1. What's the other way? 2 times 4. So those are all the factors of 8. Every single number that goes into 8 is listed right here. We want to find the biggest one of those numbers that also goes into 48 and 56. So what we want to do is just start with the biggest number of this list and see the first one that also goes into 48 and 56 is going to be my winner. So let's see. Does 8 go into 48? Just divide it in your calculator. Do 48 divided by 8 and see if it goes in there evenly. 48 divided by 8. Yep. Does 8 go into 56? We'll do 56 divided by 8. See if it goes evenly. Yep. If not, you're going to get decimal answers, right? So what did we just find? That 8 goes into 48 and 56, which means 8 goes into all of these numbers, which means I got to pull it out. It's what's in common. I can't pull out any x's, right? I look for that, but look, this last term doesn't have any x's, so I can't pull out any x's. What do I do after I pull out the 8? Well, I need to put in parentheses what is left, and that's when you are going to do what? Divide everything by what you just pulled out, which is 8. So let's see, what's going to be left here? If I took out that 8, all that's left is x squared. Plus 48 divided by 8 gives me 6x minus 56 divided by 8 is 7. Close your parentheses. Now, just because you pulled out the greatest common factor doesn't mean that you're done. I need to see if what's left inside these parentheses will factor like I've been factoring today. This 8 is part of your answer. If you don't put it in, your answer's wrong. This 8 is part of your answer. Now just finish factoring this like we've been doing today. Now it's just x squared, right? So now I know the only way to get that is x and x. Doing two things, multiplying to -7 and adding to +6. If you want to be lazy, go right ahead. If you're nervous about your signs, put it in the calculator. You're going to y equals and clearing it out again. What number do you put in your y equals? Whatever that last number is right there, sign and everything. So I'm putting in a -7. So you're at y equals, put in your -7 and then divide it by x and go down. Do it again, -7 divided by x. This time you're going to throw in a plus x at the end. Then look at your table, second table. What number are you looking for in the last column? This number right here. I'm looking for +6. So I'm looking for +6 in my last column. So go over to your last column, scroll up or down until you see a +6. I see it right there. And once you see it in your last column, what do you use? The numbers in the first two columns that make it, which is a +7 and a -1. +7, -1. All right, let's look at number 9. (3x to the third) plus 21x squared plus 30x. So, looking for what's in common. What are your numbers? 3, 21, and 30. What goes into all of them? 3 goes into 21, and it goes into 30. 3 also goes into itself, right? Everybody goes into themselves. So I'm going to pull out a 3. What else about this do you notice that they all have? They've all got an x. And remember what the rule is. With letters and exponents, if they all have them, then you just go find the one that has the smallest exponent, and that's how much you pull out. So let's see, I've got x to the third, x squared, and just x. So the smallest exponent is just that x. So that's all I can pull out is a 3x. Then remember, you're going to put in parentheses what's left. How do you find out what's left? Well, whatever you pulled out, which is going to be right here, that's what you're going to divide by. So let's see what's left. I pulled out the 3. I had x cubed, but I pulled out x1. So remember, you subtract those exponents, which means you have x2 left, plus 21 divided by 3 is 7. You had x2, but you pulled out x1, so you still have x left, plus 30 divided by 3 is 10. I had an x, but I pulled it out. So I don't have any x's left. So let's look. Bring down your 3x. Remember, it is part of your answer. Let's see if we can factor what's left in these parentheses. Now it is x squared, so it's x and x. Ways to multiply to get 10 and add to get 7. Let's see, how do you multiply to get 10? There's not that many ways. 10 times 1 5 times 2. Does one of those pairs add to 7? Yeah, the 5-2 pair does. If you're nervous, put 10 in your calculator to find the numbers that add to 7. But I'm just going to go with my gut here and say I think 5 and 2, both positive, right? Multiplies to positive 10. Positive 2 plus 5 adds to positive 7. All right, we're going to run into an issue on a problem like number 10. Negative 7x to the 6th minus 21x to the 5th plus 126x to the 4th. So I've got 3 terms. Let's see, I do see they all have x's, so I am going to pull out some x. Let's see if I can pull out some number too. If anything is going to go into all of those numbers, it's going to be a 7, isn't it? Because the only thing that's going to go, we'll talk about this negative here in just a second. The only thing that's going to go into that 7 is a 7, right? Does 7 go into 21? Yeah. Does 7 go into 126? I'm not sure. I'll just try it in my calculator. 126 divided by 7. Oh, it gives me 18. So it does go in there evenly. So I know that 7 goes into all those. Here's the deal. If your leading term has a negative with it, you're going to have to pull that negative out along with whatever else you're going to pull out. So since my leading term is a negative, I'm definitely going to pull out a negative. I just found out 7 goes into all those. How much x can you pull out? Let's see. This one has x6, x5, x4, which means your smallest exponent is x4. So that's what I'm going to pull out. Negative 7x4. Then I'm going to figure out what I have left in my parentheses. Let's see. Whatever you pulled out, which is hanging out right here, what you're going to divide everybody by. So go put it under here so you don't mess up by trying to do too much in your head. You pulled out the negative 7, so it's gone. You had x6, you pulled out x4. So if you subtract those exponents, you'll see that you have x to the 2nd. Here. Watch your signs. What's negative 21? What's this negative over a negative turn it into? Negative 21 divided by negative 7 turns it into positive 3. I had x5. I pulled out x4, which means I'm just left with x. Last one. Positive 126 divided by negative 7. I just did that in my calculator and it gave me 18. So it's a positive divided by a negative, which makes it negative 18. I had x4, but I pulled out x4, so nothing's left. So negative 7x to the 4th is part of my answer. Let's see if we can go further with what's in the parentheses now. Now, like we like it, it is just x squared, so it's x and x. I'm multiplying to negative 18. I'm going to be worried about my signs on this. So I'm just going to go straight to my y equals, clear it out. That's the number I'm putting in, my y equals. So I'm putting in negative 18 divided by x. Then what am I going to put in the second one? I'm going to do it again. Negative 18 divided by x. And I'm going to do plus x. Go to your table. Second table. What number are you looking for in your last column? It's right here. Positive 3. So I'm going to go over to my last column. Scroll up or down until I see a positive 3. It looks like I'm going to need to go up. Oh. Oh, why is it not doing it? Hang on. Oh, because I need to go down, not up. My bad. So, there's my positive 3 in my last column, which means what numbers do I need to use? I need to use positive 6 and negative 3. So, positive 6, negative 3. All right, last one for the day. Oh boy. Doesn't look anything like what we've been doing. Kind of looks like what we did on Tuesday though. So let's see if there's something in common. There's not going to be any number in common because this one just has a 1. So let's see. Do they all have M? There's an M. There's an M. And there's an M. So that all the terms do have M's, which means they've got at least some kind of M in common. Let's see. What's the smallest exponent for the M's? 3, M2, M1, which means all I can pull out is M1, so just M. What other letter do you see? I see N's. This one has 1. This one has N2. This one has N3. They all have N's. The smallest exponent is this 1, so I'm going to pull out an N. So I'm pulling out Mn, and I'm going to put in parentheses what's left. How do I know? I'm going to divide them all by Mn. See what's left. Let's see, I had M3, but I pulled out M1, which means I have M2. I pulled out the N. Minus, I don't have anything here to deal with that 9, so I have minus 9. Let's see. I had M2, but I pulled out M1, which means I still have M. And then the last thing, I had N2, but I pulled out N1, which means I still have N1. Plus 20. I had an M, but I pulled it out. I had N3, and I pulled out N1, so I still have N2. So look what we have left. It looks a little bit familiar, but I got too much going on. But let's go ahead and try to work it like we've been doing. So let's bring down this Mn and start this off like we've been doing, right? It's still a trinomial, which is 3 terms, and it's still 1 in front of your M squared. How do you get M squared? Well, M and M. Just look at the number part of this. I need to multiply to get 20 and add to get -9. Again, when I see positives and negatives all over the place, if you don't trust yourself, go to your y equals. Who goes in y equals? This number right here, which is positive 20. So I'm putting in 20 divided by x, and then 20 divided by x plus x. So it should look like this. And then you want to see your table. So go to second table. What number are you looking for? What's your middle number? -9 is what you're looking for in your last column. Okay, let me tell you another thing. If you're not getting the negatives like you want, hit this button, second, and then hit the window button, and it's got table set on it. Oh. Yeah, second table. Then tell this says, where do you want your table to start? Put a 0 right there. Just tell it 0. And then go back to second table. And then scroll up or down until you get that what am I trying to get? -9 in your last column. There's -21, -12. I'm getting closer. Ooh, I'm getting close. There's my -9. Which means what numbers do I need to put in there? -4 and -5. -4, -5. So now think back to FOIL. -4 times -5 is going to give me that +20 like I want. But I don't just need +20. I need +20 in squared. Which means, what does this -4 and -5 need to have on it? How do you get n squared? N times n. So look, -4n times -5n gives you +20 n squared. That's your answer. Okay, so on Tuesday, we're going to start doing trinomials that don't have leading coefficients of 1. They've got other numbers in front of it, which adds a whole new dimension to what we're doing. Okay, but I'll have some tricks in your calculator and shortcuts and things for you to use on that section. See y'all Tuesday.